Session 9.2, 2 means independent samples. For these sessions, the first part we're going to talk about the hypothesis testing. Second part, we're going to construct the confidence interval. So first, look at the hypothesis testing for two population means with sample standard deviation are given, okay? Sample standard deviation are given. So we don't know about the population standard deviation. So requirement, the values of population standard deviation 1 and 2 are unknown, and we do not assume that they are equal. And two samples are independent, means the population 1 is not related to the population 2. Both samples are simple random samples, and either or both of these conditions is satisfied. The two sample sizes are both large with N1 strictly greater than 30 and N2 strictly greater than 30. Or both samples come from the populations have normal distribution. So for the requirement number 4, this is talking about the central limit theorem from the session 6.4. Either both of the sample size should be really large or the original population is normally distributed. Okay, notation. So we have a two population. For the population 1, we will have an N1 for the sample size. Mean 1, that will be the population mean. Sigma 1, that will be the population standard deviation. And S1, that will be sample standard deviation. Again, I want you guys highlight this one. Sample standard deviation is given. So read the question carefully. They should given the S1. And then x bar 1, that will be the sample mean. And the corresponding notation apply to the population 2. Again, for the chapter 9, for the first step, you need to tell me which one is going to be your population mean 1, which one is going to be your population mean 2. Okay, procedure for the hypothesis testing for the population mean. So first step, write it down which one is going to be your mean 1, which one is going to be your mean 2. It doesn't matter which one is the mean 1 or mean 2, but it will affect your original claim, your null and alternate hypothesis, and also it will affect your test statistic and also the distribution. Figure out sample size, sample mean, and sample standard deviation. So the original claim depends on your claim statement here. We're gonna compare with the population mean 1 with the population mean 2. We're gonna compare the population mean 1 with the population mean 2. Figure out the null and alternate hypothesis. And if alternate hypothesis is strictly less than, there'll be left tail. Greater than, there'll be right tail. Not equal to, there'll be two tail. Okay, compute the test statistic. So remember the session 9.1 when we're working on two populations proportion, I let you guys use the calculator because the formula is complicated. But starting from 9.2, 9.3, and 9.4, I want you guys use the formula. So on the homework or exam, I would say use formula. So I want you guys plug in everything from here. Okay, we are working on the p-value method. So let's look at the left tail example. So this one, that will be your t-test statistic, which is we got it from the part 4 here. And we're gonna use the test statistic to find the area of the right tail, which is gonna be your p-value. So this is the t distribution. We'll be using the TCDF, lower value, upper value. And then we're gonna plug in the degree of freedom, but we do have a 2 sample size from here. If you guys using the calculator or some software program, they have a complicated formula to calculate the degree of freedom. But from our book, we only use the degree of freedom of smaller n. So just look at it, which sample size is going to be smaller, then you're going to use n minus 1. And then after you get the p-value, compare with your significance level. Less than or equal to will be reject. Strictly greater than, that will be fail to reject. Final works, we're going to use the section 8.1, the 1, 2, 3, 4 conclusions. So this is the first part, hypothesis testing using the p-value method. And this is how you guys use your calculator to double check your work. Second part, confidence interval. We want to find the difference of the population mean. So this is going to be your margin of error. You are using the t-distribution. And then construct the confidence interval, finding the difference of the population mean. And you could follow this procedure to double check your work. Okay, let's try the first example. The National Assessment of Educational Progress tests a sample of students who had used a computer in their mathematics class and another sample of students who had not used a computer. The sample mean score for students using a computer was 309 with a sample standard deviation of 29. Highlight this one. They given the S. So we'll be using the t-distribution. For students not using a computer, the sample mean was 303. With a sample standard deviation of 32, assume there were 60 students in the computer sample and 40 students in the sample that hadn't used a computer. Can you conclude that the population mean score differ? Use the significance level 0.05. So you can see we do have a two population here. And for the camp statement here, can you conclude that the population means? So we are working on the population means given the sample standard deviation. So first step, write it down which one is going to be your mean 1, which one is going to be your mean 2. I will let means of use a computer in their math class. Mean 2, there will be not use a computer in their math class. Okay, find out the original claim statement. The population mean score differ. Okay, so mean 1 is not equal to mean 2. And this one, that will go to the alternate hypothesis. Think about it, what's your null hypothesis? That will be opposite with this guy, right? So that will be equal to. And then we are working on two-tailed tests. Okay, this is the test statistic formula. So we are looking for the sample size, sample mean, and the sample standard deviation. Okay, with the questions, one more time, and figure out these 6 guys are here. Okay, check your work. Now, plug into the test statistic formula. Make sure when you guys use your calculator, you're gonna put the parenthesis, okay? Parenthesis on the top. And divided by square root. This square root should be covered the whole thing here. You should get 0.953. That'll be your test statistic. Okay. Number 5, distribution. We have the t-distribution, which looks like the normal distribution. And we have the two-tail. So, the area of the two tails will be equal to your p-value. And then we have the test statistic, t equal to 0.953. So, figure out your p-value. We'll be using the TCDF, lower value to upper value. And then figure out the degree of freedom. The degree of freedom, you're gonna pick the smaller n. So look at the sample size here. We have the degree of freedom 59 or 39. We're gonna pick the smallest one. So that will be 39 for your degree of freedom. So 39 will be your degree of freedom. And then for this part, lower value to upper value, we only figure out the area of the white tail. And we have two tails, so we need to multiply by 2. You should get this guy. Now compare your p-value with your significance level. Should be strictly greater than, right? So strictly greater than, that will be fail to reject. Okay, final works. 1, 2, 3, 4 conclusion. We have the two tail. Go to the alternate hypothesis, so either number 3 or number 4. And we have the fail to reject, so that will be number 4 conclusion. There is not sufficient evidence to support the claim that the mean score differ. Okay, let's use our calculator to check the work. Go to the stat, go to the test. This is a two population sample standard deviation given t distribution hypothesis testing. And we have the statistics summary. So the mean 1, 309, sample standard deviation 29, sample size 60. Mean 2, 303, standard deviation 32, sample size is going to be 40. And we have not equal to for your alternate hypothesis. For the pool here, you just keep no in here and go to calculate. So you're gonna see your test statistic 0.953 here, 0.953. And then the p here, this is talking about the p-value. So we got the p-value equal to 0.3465. That's a 0.3434. That's a bit different from our calculation because of the degree of freedom. You could see that degree of freedom is 77.95 and we only have 39 from here. Remember I say when you guys using the calculator or other software, they have a complicated formula to find out the degree of freedom. But we will just use the smaller of the n as our degree of freedom here. Okay, B, find the confidence interval. So we have this formula. First, figure out what is your confidence level. So we have the alternate hypothesis not equal to, which is going to be 2 tail. Significance level is going to be 0.05. So since we already have the 2 tail, so 1 minus 0.05, which is going to be 0.95. So confidence level is going to be 95%. And then we have this information from step 1 here. Now, figure out the critical value. We'll be using the inverse t, area from the left. Degree of freedom, we're going to be using the smaller of n minus 1. So which is going to be 40 minus 1. Use your calculator. You're going to get 2.023. So this is going to be your critical value. Now, plug in all this information into the margin of error formula. Use your calculator. You should get 12.733. Okay, construct the confidence interval. Use the sample mean 1 minus the sample mean 2, plus minus the margin of error. You should get this one. Okay, let's use our calculator to check the work. Go to the stat, go to the test. We go to the 0. This is the 2 population, sample standard deviation, t distribution, confidence interval. So we have a 309, 29 for the sample standard deviation, and 160, 303, 32, 40. And then we are working on 95%, so 0.95 in here. Go to calculate. So you should get negative 6.531 to 18.531 here. Again, you're gonna get a little bit difference from our calculation because of your degree of freedom. The degree of freedom is gonna be affect your critical value. Okay, but it should be really, really close to the answer. Number 2, a study is done by a community group in 2 neighboring colleges to determine which one graduate students with more math cards. College A samples 11 graduate. Their average is 4 math cards with a standard deviation of 1.5 math cards. College B samples 9 graduate. Their average is 3.5 math cards with a standard deviation of 1 math cards. The community group believes that a student who graduated from College A has taken more math cards on the average. Both populations have a normal distribution. Test at a 1% significance level. So first, let the mean 1 and mean 2. I will let the mean 1 will be the means of College A, mean 2 will be the means of College B. What is the original claim? The claim statement will be the community group believes that a student who graduated from College A has taken more math cards. So the mean 1 should be greater than mean 2. And this is going to be go to your alternate hypothesis. Okay, strictly greater than. That will be the alternate hypothesis. And null hypothesis is going to be opposite with this guy. And this is going to be white tail. Okay, I have the test statistic formula. So I know for the step 1, I need to figure out these 6 guys. Okay, check your work. Plug into the formula. Use your calculator. You should get 0.8899. Okay, distribution. So we are working on the p-value method. We have the normal distribution with the white tail. And the area of the white tail will be equal to your p-value. So we're gonna use the test statistic to find out the p-value. And this is a t-distribution, so we're gonna use the t-CDF. Lower value, upper value, the smaller of n-1 here. You should get 0.1997. So use your p-value to compare with your significance level, which is going to be strictly greater than. So fail to reject. Okay, conclusion. 1, 2, 3, 4 conclusion. Original claim statement, go to the alternate hypothesis. So either number 3 or number 4. And then fail to reject. So that will be the number 4 conclusion. Okay, find the confidence interval. So first, we have the alternate hypothesis is going to be greater than. That will be white tail. Significance level is going to be 0.01. So we're going to make up the left tail. Significance level is also 0.01. So we are working on 98% confidence level. And we have this information here. Find out the critical value. So that will be inverse t 0.99. Degree of freedom is going to be smaller of n minus 1. So that will be 9 minus 1 here. Use your calculator. You should get 2.4490. Okay, plug in to your formula. Use your calculator. You should get this guy. Then construct the confidence interval. Plug in all these numbers. Use your calculator. You should find the difference of the confidence interval equal to this. Again, if you guys use your calculator, it may be a little bit off from your answer because of the degree of freedom. Okay, last one. And this time we'll be using the critical value method. Based on a simple random sample of 52 juice-fast dieters, juice-fast dieters mean net weight change after 3 months is negative 21 pounds, with a standard deviation of 12.4 pounds. Based on a simple random sample of 61 paleo dieters, paleo dieters mean net weight change after 3 months is negative 25 pounds, with a standard deviation of 16.7 pounds. Use the critical value method and a 2% significance level to test the claim that juice-fast dieters and paleo dieters have the same mean net weight loss after 3 months. So first step, write down the mean 1 and your mean 2. I will let my mean 1 equal to juice-fast dieters mean net weight. And mean 2 will be the paleo dieters mean net weight. I want you guys try to do it by yourself. Do number 1, 2, and 3. Okay, check your work. You should have this information. Since this is talking about the weight loss program, so their sample mean will be negative. Means like their weight is going to be decreasing. Original claim, they have the same mean weight, right? So mean 1 will be equal to the mean 2. And this is going to be go to the null hypothesis. Alternate hypothesis, that will be not equal to, with the 2 tail. Okay, distribution. We are working on the critical value method. So we have 2 tail, and think about it. What is the area of this 2 tail? That will be equal to your significance level, 0.02. Okay, sum of the area of the left tail and right tail will be equal to 0.02. So when we have a 2 tail, how many critical values do we have? We will have 2, right? Because we have a positive and negative, plus minus. So figure out the critical value, we'll be using the left tail area here, which is gonna be 0.01. So inverse t, 0.01, the degree of freedom. You should get 2.403. You should get negative 2.403. But you know you have two tails in here. So you do have a two critical values. That's a plus minus. So let me write it down here. And then figure out the test statistic. Plug into the formula. And this is the sample mean 2 will be negative 25. So negative, negative, you're going to get the positive in here. And you should get 1.4578. Okay, this is the critical value method. After you find the test statistic, show me where is your test statistic located. Should be in the critical region or is not in the critical region. 1.4578 should be somewhere like here. Draw the conclusion. Since the test statistic is not in the critical region, that will be fail to reject. Okay, conclusion. 1, 2, 3, 4 conclusion. Your original claim should be go to the null hypothesis. So either number 1 or number 2 conclusion. And we have failed to reject, so that will be number 2 conclusion. So there is not sufficient evidence to warrant rejection of the claim. On the homework and exam, when you guys using the critical value method, I need to see this picture. Okay, tell me what is the area of your left tail, right tail, or two tail. Show me your critical values and show me where is your test statistic located. Okay, B, find the confidence interval. So we have not equal to two tail. Since this is a two tail, so the confidence level will be 1 minus 0.02, which is going to be 98%. And we have this information here. Figure out the critical value. So that will be inverse t 0.99, the smaller of n minus 1, which is going to be 51 here. You should get 2.4071. Plug into the formula. Use your calculator. You should get 6.6048. Then construct the confidence interval. Okay, plug in the numbers here. You're gonna get negative 2.6048 to 10.6048. That's it for the session 9.2.